Our first speaker is Graham Barrett, who's talked to us about his absolutely amazing program for toric IOL prediction. Graham?
Thank you, Doug, and thanks to Haag-Streit for the invitation to talk about toric IOLs. Here are my disclosures. When I think about it, toric lenses have made the most dramatic change in the last decade to outcomes that I can recall. And that's because it's changed our practice, it's changed the results that we get. So here is a graph that I presented in 2006 when I had done my first maybe 20 toric lenses. So I'm comparing the pre-op keratometry to the post-op refractive sill. It's rather primitive, Doug, I apologize for that type of analysis, but it showed it worked. It also showed there was quite a bit of variation. The standard deviation is quite high. And like most surgeons, when I began, I initially was conservative and used these lenses for astigmatism. You see my average there is about 1.5 diopters, so for patients with higher sills. And today I use toric lenses in about 80% of my cases that I do cataract surgery. And what's changed that is improved astigmatic outcomes. And it's improved because now we have a better understanding of how to use multiple devices. We understand how to interpret measurements, and also we have better methods of prediction. Now, there's many devices available today. There's the manual keratometers, Javel-based, BNL keratometers, there's different biometers, there's topographic devices, some based on video keratography, some based on Scheimpflug imaging, and even on the horizon OCT-based devices. And I think the best way to understand the utility of multiple devices is to embrace the philosophy of one of my co-speakers today, Warren Hill, and that is the idea of primary and secondary devices. So Warren is not just a pilot, but he's actually a stunt pilot. He'll scare you if he shows you some photos with wingtips not being very far apart. So he relies on the attitude indicator to show his orientation as his primary instrument, but he always has secondary instruments to confirm that primary instrument. And that same concept applies to choosing toric lenses. It's also a critical activity. And so I always use 3 devices. My biometer, my LENSTAR, is my primary instrument, both for magnitude and axis. Some people have different devices for their magnitude and their axis, but I use the biometer as my primary. But I always confirm the validity of that measurement with the manual keratometer and the topographer, which in my case is a Scheimpflug device, desiring a keratometry measurement that I'm going to use somewhere in that triangle of agreement. And this brings us to prediction, different methods of prediction. And there's several options you have. The standard method, the Toric Calculator, uses a fixed ELP to calculate the toric lens power required to correct the corneal astigmatism. More sophisticated, the Holiday Calculator uses a variable ELP dependent on the ELP prediction of the Holiday formula to do the calculation of the toric lens power required to correct the corneal astigmatism. Now you can modify both those calculators using nomograms or regressions such as Doug's Baylor nomogram, and you can modify them if you like, either of those 2 methods, using direct measurements from Scheimpflug devices or OCT devices. Or you could use the method and the calculator which I developed, which is based on a theoretical model which I came up with actually after hearing your lecture, Doug. And it was a model to try and explain the behavior that Doug had observed and people had observed going back maybe 100 years. And it's simply this, that the corneal diameter is always greater in the horizontal meridian than the vertical meridian. And that means that the corneal radius is always steeper vertically than horizontally. And that explains, this elliptical cornea explains the half adopter against the rule corneal astigmatism, which we can't measure when we measure the anterior surface. And one of the features of my universal 2 formula is that it enables me to calculate the horizontal and the vertical diameter for each individual patient. And it also provides the ELP that I can then predict accurately using Gaussian optics the required toric lens to correct the corneal astigmatism. So it's not a regression base, it's a theoretical formula. And it's been available online on Ascris website for a while, but a huge advance was when LENSTAR incorporated, Haag-Streit incorporated this formula. It's available on the LENSTAR. It's the only device at present where it is available. And this saves you from entering data manually, which is always prone to error, and obviously it does take some time. So it's a very nice thing to have available on a biometer device. Now, when we look at comparisons of different methods of calculation, you can see a distinct difference between the outcome, say, with the holiday calculator, maybe 28% being within a half diopter versus the online and Haag-Streit Toric Calculator, where we have about 75% plus. And this has been published. I'm not going to talk too much about results. Adi's going to talk about the studies which, thanks to his efforts, have been published in 2 journals last year, JCRS and the Journal of Refractive Surgery. Now, an alternative to the theoretical method is regression. And regression works very well in the lower dioptric cylinder powers, say 1.5 diopters or less. But as you increase the cylinder correction, this is in 160 eyes, it's a recent analysis which I've done on my own cases, you can see that the regression method tends to decline somewhat in predictability, whereas the blue line, and that's my own theoretical calculator, that accuracy is maintained throughout the dioptric power range. Now, another formula on the LENSTAR, which you may or may not be familiar with, is the TrueK formula, and this is used for post-refractive patients. This is a paper only published last month, and it shows you that the percentage of patients within a half diopter of prediction was significantly higher using the TrueK formula than other methods available on the Ascris website. And that's been published, but more recently I looked at 28 eyes who had RK. These really are the challenging cases. And with the TrueK, because it can be used for myopic, hyperopic, or RK, but for the RK cases, 85% were within a half diopter, which is a good result. And that's with the refractive history. If you don't have the refractive history, not quite as predictable, drops down to about 78.5%. But one of the challenges of calculating toric lenses in people who've had refractive surgery is that your measured K is not appropriate to derive the posterior cornea, nor is the measured K appropriate to predict the ELP required to work out what the toric lens power at the corneal plane is. And so you really need something custom specific for post-refractive patients to calculate toric IOLs. And so I've developed a new formula called the TrueK Toric Calculator. It's available on the APA-CRS website only as of last week, and it's got the right maths. So whether you're doing myopic, hyperopic, or RK case from previous surgery, it will give you a correct toric calculation. So here is an analysis on 29 cases, post-myopic, hyperopic, LASIK, or RK, and you can see that with the holiday calculator, 48% are within a half diopter of predicted residual astigmatism versus about 75.9% using the TrueK Toric Calculator. And we did another study, an analysis, because I was interested to see what was the impact of different factors on errors in predicted residual astigmatism. And you can do this by doing the analysis using pre-op versus post-op Ks, using intended versus the actual axis of the IOL, and different calculators. So there's really 3 different scenarios, which I'll show you in turn. So the first scenario is one where you're just using the assumed value for SIA and you're assuming that the lens is sitting where you intended to. And if you use this first scenario, and many of us operate that way prospectively, you can see that using the standard Alcon calculator, only just over 10% will have a predicted residual astigmatism within a half diopter. Not surprising, we've been conservative about reserving these devices, toric lenses, for people with higher cylinders. But using my own calculator, about 50%. But this is using the median SIA value. That's just the magnitude, mean magnitude or median magnitude of your SIA. But that's not really appropriate because it ignores the axis. And unfortunately, the axis of the induced astigmatism does not stay as you would expect within the meridian of the incision. It's all over the place. So when you add up all these vectors and you get the mean vector, that's what the centroid value is, and it's only about 0.1 diopter or less. So if you put in the centroid value, 0.1 diopter, you see both calculators improve. So it's a misconception that the centroid is something you only use for my calculator. It's not true. For any method of toric calculation, that's the correct value you should use. It's the best we can at this point in time. Now, if you then, scenario 2, you use the post-op Ks. So you've taken out the variability in the SIA using the post-op Ks in the analysis. You can see there's a significant improvement in the prediction of both formulae. Now we're up to over 70% with my calculator and 25% odd with the Alcon calculator. And if you measure where the lens is sitting, not where you think it's sitting, not the intended axis, once again there's an improvement in the predictability. So this is just showing the contribution of the different factors. The blue column is a difference in the calculators, the red's excluding SIA, and the green is the axis misalignment. And from the study, you can see that SIA is a confounding factor in predictability. The best thing you can do is to use a centroid value, which is going to be 0.1 typically for a 2.4 millimeter incision. Obviously, try and reduce your error of alignment with your lenses. Certainly in my cases, it's not a major impact as you see here. And an improved calculator does make a significant difference. So my final thoughts is that I find multiple devices, 3 instruments using Warren's concepts of primary and secondary instruments to interpret the device very useful. An improved calculator will change your outcomes dramatically. And be aware that for post-refractive cases, it's really ideal to use a toric calculation method which is specific for post-refractive cases such as the TrueK toric calculator. So I hope in that 10 minutes some of these pearls will be useful to you in your practice and improve your outcomes. Thank you for your attention.